Welcome to Science and Engineering World, where we do mathematics, more mathematics, much more mathematics.
I welcome everyone to class, and I trust you have been doing some studies. Great. In this presentation, we shall continue with our study of the quadratic equations. And remember, we started with the derivation of the completing the square, which led us to almighty formula, also known as quadratic formula. I'll put a link to that video up here and in the description box below. We have been solving a particular quadratic problem so that we can see the solution across every method of this quadratic equation. And we started by looking at the completing the square itself, which I will put the video link up here and in the description box below. We've also looked at factorization methods, and we saw that the solution we obtain in the quadratic method is also the same solution in the factorization method. I'll provide a link to this video at a later time before the end of this presentation. Now, we want to look at a graphical method, and I believe you will enjoy it. My name is Olutola Fakehinde. Solving quadratic equation graphically. We have solved this problem 2x squared plus 11x minus 40 equals to 0 using two methods, completing the square and the factorization methods. We arrived at the same roots of this equation with both methods. Let us see, using graphical methods, whether we will arrive at the same roots of this equation. Okay, let us go together step by step in looking at the solution to this quadratic problem 2x squared plus 11x minus 40 equals to 0 using graphical method. The graphical solution to this problem should look similar to this, which we want to obtain at the end of this presentation. As we've done previously, we shall go in steps in solving this problem. Step 1 here says we should represent this quadratic equation in graphical standard formats, and this will enable us to present the equation in two-dimensional picture as we have seen above. We now need two axes, the x-axis, which is abscissa, which is always horizontal, and the y-axis, which is vertical, going up. So we have the y as the ordinate and the x, which is the abscissa, on the horizontal and the vertical. Now we have x variables in this equation, and these will be presented on the horizontal axis. For us to have the y-axis now, we need to replace the 0 here with y. So we're going to have y equals to 0. And we'll see this as we go on, that is very significant. So we can rewrite this equation as 2x squared plus 11x minus 40 equals to y. So we have our two axes that is going to be represented here, the x and the y axis. In step 2, we want to take a reasonable scale. For now, let's take a scale of x to be between -9 and +5. I will give a more explanation on this before the end of this presentation. In step 3, we want to find the values of y in all the values of x in this scale that we have taken. For example, when x is -9, so we use -9 to replace our x here and also our x here. And that will give us this expression y equals to 2 minus 9 squared plus 11 times -9 minus 40, which will give us 2 times 81, because -9 times -9 is plus 81, plus 11 times -9, which is -99, minus 40. And that gives us that y equals to 23. So we need to repeat this for every values of x in this scale. In this step 4, we want to present the values of x and y we obtain in step 3 in a neater form, which is the tabular form, and which we have here. Here we have this x is what we have from the scale. So from the scale we transfer that to this, and for value of y is the summation of everything here, which is what we present inside here. And so we use it to obtain our values of y. One important point here is that the more values of x we use in this case, the smoother our curve will be. What do we mean? In this between 9 and 8, between -9 and 8, I put a middle point which is -8.5. Same thing between -8 and -7, I put the middle point -7.5, and so on and so forth. This will give us a more accurate curve by the time we plot these points in our graphical format. In this step 5, we want to present the x and the y values we've obtained in a graphical paper. Manually, we can do this. We have the x on the horizontal, as the x-axis on the horizontal, and the y on the vertical. Now, graphing our values, we have to take scales on these two lines. Depending on the values we've obtained, both on the x and the y, we determine the scales that we are going to use on these two axes. Now, on the x-axis, we have even values -9, -8.5, -8, -7.5, which are even, and this we can represent, but we have minus on this side. We can represent it by equal distance. So we have to have equal distance on the left hand side and on the right hand side. Then for the y-axis, which is also varying, we have to determine the values on the y-axis to be able to determine the distance. The distance on the y-axis does not have to be the same on the x-axis. Now, here we have a larger value on the y-axis, so we need to take a smaller distances between them. So we have smaller scale, but they have to be the same for both up and down. Now that is scaling our axis. From here, which I've done before, is that we can see the scale on the x-axis, which is put as -2, -4, -6, -8. In between them are the values of 1, 3, 5, 7, 9. And same thing on the right hand side. And then on the y-axis, we can see the scale is now 10, 20, 20, 10, 20, minus 10, minus 20, because the values of y is larger than the values of x. So the scale on y is different from the scale on x. This will not affect our plotting of the graph. Now, let's see plotting. When x is minus 9, which is here, y is 23. So y23 is approximately here. When x is minus 8.5, y is 11, which is 8.5 is in between. So this is 8.5 and 11. And then we have again minus 8, which is here, and the point representing it is 0, and that is here. Now, this is an important point which we will talk about later on. And then we have minus 7.5, which is in the middle here, and the points on the y-axis is minus 10, and so on and so forth. So with that, we now join the points together with a smooth curve. The graph we are trying to plot above will take us some time to draw manually. And the second point is that it may not be that accurate because we are using manual process to plot it. Now we want to do a simulation on Excel so that the curve will be smoother and more accurate. Now we're going to use the same scale that we use here in the Excel presentation. So let us go to that presentation. Here we are in Excel spreadsheets to plot our graph of equation y equals to 2x squared plus 11x minus 40. And we have our range of x starting from minus 9 to plus 3. First, let me make this sheet a little bit cleaner by removing the grid lines, and then we plot our values. So we need the values of x. So we start with our x here, and then we put the range from minus 9. So minus 9. Now, like I said, we want the points to be very close so that we can have a good curve. That's minus 8, minus 7.5, minus 7, minus 6.5, minus 6. Let's stop here because Excel has an intelligent way of continuing a pattern. So it can generate the remaining values for us. So we draw this down to that point where we want it to be, so we can see as we are drawing that down, it's showing the range, and that is 0.3 there, where x equals to 3. Now we want to calculate the value of y. The value of y is taken from this equation. We want to put that in the formula bar where we say equal to what? Equal to 2 times x. Now our x will be taken from the value we have here, referencing that value x, to the power of 2, that is the square, plus 11 times x again, we reference that cell again, x, and then minus 40. So by the time we enter here, it's going to generate the value for us. So we have the value of y when x is minus 9 to be 23, and we've seen that at the top there. Again, to generate the remaining values for us, all we need to do is to let our handle here and double click on it, and it will generate that value for us. That is the beauty of using Excel, and this is why I say Excel is easier and faster. Now we want to plot the graph. So we highlight the values that we have. So we are having x and y values. We highlight that value. Yeah, we want to stop there. So that's the range of values we have for x and y. So we go to insert and insert a line graph, which is here. Is a line graph, and then we can pick up that. We can see from here that the x is not on the horizontal. So we need to change this graph, the type graph, and change it to the one that will give us an horizontal axis for x. And that has been generated by changing that. Now, we want to, as much as possible, present this in a neater form. You can start with formatting the lines. We have our line in the form. We want to change it to a red line if possible, or any type of color you want, but I'm choosing red for the profile we have here, and I want to make the line a little bit thicker by choosing maybe like 3 points here. I'll make it a little bit bigger. And then we want to remove the grid line inside here. We don't need it, so we can just click on one and delete it. Also, we don't want the legend, because we know it's just one simple line, x and y. And we can also remove the title there. This will make our graph bigger. Then we click on the x-axis and make it bolder as well by going into that and increasing its fonts from 9 to 12. We can make it bold. X line can be made bold as well, so we can make it a black line and give it a small a more width, like about 1. On the y-axis, we do the same thing. We make it bold. We have the fonts for the x to be 12, so let's make it 12 there. 12, and make it bold. And then its line also to be black, 1. So we have our graph here. This red curve is the profile of y equals to 2x squared plus 11x minus 40. So we can bring it to the graph, and so we have that. We can draw a line to make it to point to the curve itself. So we have An arrow pointing from here to the curve. Let's give it red line and an arrow pointing towards it. Then let's have our border for the equation itself, which could be, let's make it a red line as well. And we can also make the letters to be red, so everything there is red. Next thing we want to look at here, because all we are after is to find the roots of this equation. So the roots of the equation, like we have said, is where this curve intersects with the x-axis. That is when y equals to 0. Remember, we have replaced 0 here with y. So wherever y is 0 and where the curve intersects axis will be our roots. And we can see here that y is intersecting with that, and let's give it a label of call out. Let's give it a call out label, which we can bring up. And again, we can format it to make it bold to 12, like we have done before. Make it bold and give it a red letter as well. So that is the first root of the equation, which we have seen it is conforming with what we had before in the other methods. Again, on the plus sign, we have another point where the curve intersects with x, and that is the second root of the equation. And let's give it a call out of that and bring it up. Okay, then let's format it as well. Increase the fonts to 12. Make the lettering red. So we have successfully plotted the profile of this equation, and that is our red line there. And we can see again that the roots of this equation, -8 and 2.5. 2.5 is 5/2. Wow. That was quick, easily done. QED. The exact simulation was very fast. That's number one. Number two, very accurate. Again, we have seen that the roots of the equation, the same that we obtained when we were doing the completing the square and factorization methods. So we have a root of x equals to 5/2, which is 2.5, as we've seen on the graph, and x equals to -8. And like we have said, these roots are where the curve cuts the x-axis when y equals to 0. Yes, having obtained our values of x, that is the roots of this equation, we need to verify if they satisfy the equation itself. This is where I said I will put the link of the factorization method we have done above, because the roots we obtain both in factorization and here are the same, and we have done the verification thoroughly in that video and even in the one of the completing this square that you have the link earlier. Okay, so we move on to the next step. Now let's do something different from what we have been doing before. Earlier on we have an equation and we are asked to find the roots of this equation. We have used the completing the square method, we've used factorization, we have also used the graphical method now. Now we want to go a step further and see if we have the roots, can we form an equation from there? For example, we have here the roots. One root is x equals to minus 6 and the second root is x equals to 8. So we have these two roots and we want to form an equation from it. Not only that, we want to use this equation to plot the profile of the equation just like we have done earlier on. Very interesting. Let's do this together again. So in order to use the roots to form the equation, we need to express these roots in the form of factors of the equation itself. Remember, we are given a root to be minus 6 and the other roots to be 8. So in this case, we want to express these two roots in form of its factors. So we have here x equals to minus 6 and x equals to 8. What we're going to do is to shift this into the other side and similarly shift that to the other side. So for us to do this, in the first one we need to add 6 to the right hand side and we must add it to the left hand side. So we are going to have x plus 6 equals minus 6 plus 6, and we are going to do similar thing on this side as well. So we have here x plus 6 equals to minus 6 plus 6, and the same thing on the other side, x minus 8 equals to that. So we find out now that on the right hand side, this x minus 6 we cancel plus 6, and the same thing on this side, plus 8 minus 8 we go, and we have our expression x plus 6 equals to 0 and x minus 8 equals to 0. If you have a equals to 0 and b equals to 0, we can write the two of them together as a b equals to 0, because for the left hand side to be 0, a must be 0 or b must be 0, which is the same thing we have expressed above. So in that case, we can combine this and this together. So this can be our a here and that will be our b there. And so when we bring them together, it's going to be a times b. So our a will come there and our b will come there. So we have these two factors. In this step 9, we want to expand the bracket or remove the brackets. So what we're going to do is we are going to have here x, we multiply this one, and x we multiply that, and that will give us x squared minus 8x. And then we're going to also have 6, we multiply that, and 6 we also multiply this. And that will give us plus 6 times x will give us plus 6x, and plus 6 times minus 8 will give us minus 48 equals to 0. And so we need to now combine the x. So we have x squared minus 8 plus 6, because 8 is larger than 6, so we are going to have minus 2x minus 48 equals to 0, and we transfer this to that form to give us x squared minus 2x minus 48 equals to 0. So we formed our equation from the roots. So we need to get the profile of this equation. In that case, we need to have it represented in form of a graph, and we go through the same process we have done above, and we are going to transform this equation to the standard graphical form, which is replacing 0 with y. So in order to find the profile of this equation, we now need to plot it on a 2D picture like we have done before. But before then, we need to find the range of x. This is where I said I was going to explain that range. Now, we have seen that the roots of this equation are minus 6 and plus 8. The range of x should cover these two. So in this case, we can move from the left hand side, we can do 7 minus 7, that will cover minus 6, and then we can do plus 9, that will cover plus 8. So we can now have a range of x between minus 7 and plus 8. So a knowledge of the roots of the equation will make us to be able to give adequate range of x. Now let's go to Excel to plot this profile like we have done in the previous one. Welcome to Excel Simulator, where we want to plot the equation we have obtained from its roots. That is the equation that says y equals to minus 2 minus 2x minus 48. Great. So here we can use a range that includes the value of the roots. So the value of the roots here is, like we have seen, we are given is minus 6 plus 8. So we want to be able to get a range that will include those two values. So we have here minus 7, which we include minus 6, and then plus 9, which we include plus 8. So we are using this range to be able to plot this particular equation. Now we're going to use the same graph that we have plotted by adding this curve onto it. Now the range is from minus 7. Let's call this one y2. And the range is starting from minus 7. So we are going to put our formula, this formula, under -7. So we now say equals to what? Equals to x squared. Remember, we are referencing this side, which is x squared. So we square that. And then we have -2 times x. Again, we reference that cell again. Then -48. So when we enter, it gives us that value. However, we are taking the range to +9. Then let's ask Z to do that for us. So we're going to have extend this range to +9. So we're going to extend this range to +9. +9. Good. So it has extended the range to +9. Now we want this to also generate the value for y to +9. So we put the handle here and double click, and it should generate that value. So it has done it for us. This is the beauty of Excel. Very handy and useful. Now we want to plot the graph into this graph page. All we need to do is to extend the shaded part here to cover the value we've just generated. So we just come here. Boom! It plots the graph for us, which is very interesting. So this is the graph of our curve. Now to distinguish the two of them, let's change its color. We change the color to something like green, maybe green. Yeah, green should be good. So we change to green. Increase its thickness by going to 3, which we have for the other one. And then we have it. So let's represent that equation as well. So we want to bring this equation in, and then take it in here. Okay. Now, let me extend this, because when it plotted that graph, this red graph shifted. Again, we want to find the roots of the second curve, which we have said it's at the point where the curve touches or intersects with the x-axis, and that is when y equals to 0. So we have that point here. I have a call out for it. Call out to that point, which will give us -6. Remember, our root is -6. One of the first roots given is -6. So let's make it the second. Let's do the second call out first. Again, this is at the point of give it a call out. Bring it somewhere here. Then we format it, make it bigger. So again, we have seen the root of the second curve, which is here, that curve here, to be -6 and +8. If you remember, these are the values given for us to generate this equation. We can format the sheet, the plots, by giving it a small, maybe like a press pull, and then let's give it a color. This is beautiful. We can go further to label the axis by giving it x-axis, x-axis, and we can repeat that for the y-axis. The other way. Good, that's better. The two equations are being plotted in Excel. We have the profile of the first one, which is y equals to 2x² plus 11x minus 40, which is the red one, and the roots are -8 and 5/2, which is 2.5. And for the second one that we are given is roots to be -6 and 8, we are able to generate its profile in that green line. Another point we'll be looking at a later date are these points where the curve turns, which is the vertex point, and here again the vertex point. So we need to be able to find this, but it is not for this particular presentation. So in another presentation, we'll be looking at these 2 points here. Wow, wow. We've done it again. Yes, we've been able to plot the profile of the equation. Now we can see from the graph that the roots of the equation that we are given are the same as what we got on the graph. X equals to -6 and x equals to +8. And like we said before, these are the points where the curve intersects the x-axis when y equals to 0. And the expression or the equation that we obtain from there is x² minus 2x minus 48 equals to 0. So if you enjoy this presentation and you find it very useful, do few things for me. Number one, give us a thumb up. Number two, share with others so that people can start enjoying the same thing we enjoying here. And number three, make comments. Make comments so that we can know how you feel about this, and if you have any problem, anything that you want us to explain further, please put it in the comment section below. Again, I always encourage everyone to subscribe to this channel. Your subscription will go a very long way to help us. It's a form of encouragement for us, and it can also take our video to other parts of the world. There's a subscription button here. Please press it. Please press it. And also, I always say, mathematics can be funny. So keep having fun. And until we meet next time, keep studying.